If we delete the limits, the most dazzling divine body I perceive is the one that may be uncommon in our sky. It is this one, Bug Squeeze. It's an enormous, red, very Goliath star, and on the off chance that you were to situate it where our Sun is, it would stretch out completely to the circle of Jupiter. This monstrous, very temperamental star is very nearly detonating. It's not as direct as it may seem. In the universe, these titanic occasions, like the most extreme supernova, could shake all that we notice and even things we don't. However, we can't see it clearly. Bug Ju is thought of as an image of a red, very Goliath star, ordinarily much larger than our own Sun. Brian Cox, along with other astronomers, believes it could explode in a supernova soon. People have grown increasingly worried about what will happen since the James Webb Space Telescope has been capturing astounding images of the star. When exactly will Bug Juice erupt into a supernova, and how critical will the impact be on the planet? Let's dig into a star in the wonderful Orion constellation, which shines so brightly that even ancient civilizations noticed it. The awe-inspiring star, Insect Ju, dwells on the eastern shoulder of the Orion constellation, ranking as the second-largest star in Orion. Its name comes from this location, marking it as a shoulder star. Insect Ju is likely one of the brightest stars visible in the night sky. However, despite its brightness, the star emits an unusual red tone, which, as we will explore, signals possible danger. Humanity has long studied Insect Juice. Greek astronomer Tmy noticed it long ago. At that time, the first thing people recognized about stars was their color. Tmy noted that the star appeared to have a reddish-orange tone, a disturbing sign. Lately, researchers have been studying the star with even more precision, and they now have a much clearer understanding of what makes it so strikingly radiant. One of these factors is that the star undergoes significant variations in brightness, fluctuating by as much as 0.6. Scarab Ju is a variable star, meaning its brightness changes periodically. In 2019, scientists discovered new behaviors in the star that had never been seen before. Despite the fact that creepy crawly juice didn't stop shining completely, its radiance significantly diminished. It dropped to a level of around 1.6, prompting experts to investigate why such an anomaly was occurring in one of the brightest stars in the sky. They hoped to find an explanation for why Betelgeuse was acting so unpredictably. According to their findings, Betelgeuse could explode as a supernova at any moment. Brian Cox, a renowned scientist, shared this concerning evaluation. As a distinguished professor of particle physics at the University of Manchester and the Royal Society's professor for public engagement with science, his opinion carries weight. He also presents popular science TV programs and writes books, making his perspective widely respected. Brian Cox explained that Betelgeuse seems like a ticking time bomb, one that could erupt with very little warning. To support this claim, the James Webb Space Telescope has provided significant evidence. However, several characteristics of Betelgeuse have raised many questions. Why does Betelgeuse behave so strangely in terms of its variability? With the new data, Betelgeuse has secured its place as a potential supernova candidate. However, scientists still don't know when the explosion will happen. The fact that Betelgeuse's mass is nearly twice that of the Sun supports this classification. Generally, stars with at least a few times the Sun's mass are considered potential supernova candidates. But things get interesting because scientists have used various tools, such as the James Webb Space Telescope and the Laser Interferometer Gravitational Wave Observatory, to investigate Bug Squeeze and uncover the mysteries surrounding the star. What they found is still shrouded in mystery. Betelgeuse was born on August 31st, a very long time ago, and since then, the star has been emitting strange signals that make its future uncertain. What did they find? They detected unusual light waves coming from the star, which raised further interest. However, this wasn't the only strange occurrence. It brings us back to the fact that Betelgeuse is a variable star that fluctuates in brightness. There were reports that Bug Ju had regular dimming episodes, similar to sunspots on our Sun. However, the cycles were different. It shifts between bright and faint phases twice as fast as it once did. Another odd sign that Betelgeuse is behaving strangely came in February 2021, when the star's dimming cycle reached a brightness level of just plus 1.61. This happened not long after the star had experienced a massive dimming event, marking the beginning of its unusual behavior and raising alarms that Betelgeuse might be approaching the end. The huge dimming event between 2019 and 2020 which reached its lowest level, convinced many experts that the star would explode within the next 100,000 years. However, when Betelgeuse brightened again after this remarkable dimming, things became even more puzzling. Physicist Andrea Dupree, from the Harvard-Smithsonian Center for Astrophysics, observed that the star was now 150% brighter than normal, making it the seventh brightest star in the sky. Scientists were bewildered to see a red glow emerging from the southern part of the sky. What was happening only became more confusing. This development sparked various theories about the cause of Betelgeuse's dramatic dimming. It's essential to highlight that not every star emits the same red glow that Betelgeuse does. This glow marks Betelgeuse as a red supergiant star, which is the final phase of a star's life before its death. This red tint results from a surface temperature of around 3,500 Kelvin, significantly cooler than the outer layer of the Sun, which is around 5,500 Kelvin. Since bug juice is cooler than the Sun, it emits less energy per unit of surface area, even though it is much larger and on the verge of exploding. We should also consider the phenomenal dimming event that Brian Cox questions. Does it really mean that creepy crawly Jew will go supernova? The fact that Scarab Jew is now in its red supergiant stage indicates that it is approaching the end of its life as a star. A star in this stage will often dim as it dies, and this is something scientists can detect. However, Betelgeuse's recent strange behavior has made scientists focus even more on monitoring it. Today, various telescopes are observing this unusual dimming event, trying to gather more insights. Things continue to get even more interesting because experts still do not fully understand Betelgeuse's behavior. Using cutting-edge instruments, scientists are watching the star closely. The James Webb Space Telescope has been one of the most valuable tools since its launch in 2021, helping astronomers gather new, crucial data about Betelgeuse. The telescope's images of the star's dramatic dimming have shown that the event caused a massive mass ejection, about 400 billion times more massive than a typical coronal mass ejection. The James Webb Space Telescope can also observe things invisible to the naked eye, such as specific wavelengths of light, making it an invaluable resource. Researchers have observed dust clouds forming on the star's surface that appear to resemble leaves in space, an odd but fascinating discovery. Despite everything, Insect Jew is undoubtedly. Will we witness Betelgeuse's supernova? The possibility of witnessing Betelgeuse's explosion in our lifetime is both thrilling and uncertain. Since astronomical timescales are vast, predicting the exact moment of a supernova is incredibly challenging. While some signs suggest an impending explosion, the truth is that it could still be thousands or even hundreds of thousands of years away. What makes Betelgeuse so intriguing is its unpredictability. Unlike other supergiants that follow a more stable evolutionary path, Betelgeuse has displayed erratic brightness variations, mass ejections, and unexplained fluctuations that have left scientists puzzled. This behavior has fueled speculation that the star is much closer to its final explosion than originally thought. What would the supernova look like? If Betelgeuse were to go supernova, the event would be visible from Earth with the naked eye, even during the daytime. At its peak, the explosion could outshine the full moon, making it the brightest object in the night sky for several weeks. During the initial explosion, Betelgeuse would rapidly release an immense amount of energy, causing its outer layers to be expelled into space at incredible speeds. The light from this event would take about 642 years to reach Earth, since the star is 642 light-years away, meaning that if we see the explosion today, it technically already happened centuries ago. Astronomers predict that the bright phase of the supernova would last for weeks, gradually fading over months and leaving behind either a neutron star or a black hole, depending on how much of its core remains after the explosion. Would a supernova affect Earth? One of the biggest concerns people have is whether Betelgeuse's explosion could harm Earth. Fortunately, astronomers reassure us that it is far enough away, outside the danger zone of about 50 light-years, so its radiation and shock waves will not pose a direct threat. However, the supernova would produce vast amounts of cosmic rays and gamma radiation, some of which might reach Earth. But our planet's atmosphere and magnetic field provide excellent protection against these high-energy particles, meaning there would be no significant impact on life. The most notable effect would be on the night sky. The remnants of Betelgeuse's explosion would create a stunning supernova remnant, similar to the Crab Nebula, which formed after a star exploded in the year 1054. This glowing cloud of dust and gas would be visible for thousands of years, serving as a cosmic reminder of the event. Scientific breakthroughs and future observations. The explosion of Betelgeuse would be a once-in-a-lifetime opportunity for scientists. Modern telescopes, including the James Webb Space Telescope, the Hubble Space Telescope, and powerful ground-based observatories, would capture detailed images and data in real time, providing unprecedented insight into the final moments of a massive star's life. Additionally, observatories designed to detect gravitational waves and neutrinos would receive signals from deep within the collapsing core of the star, helping scientists understand how these violent explosions unfold at a fundamental level. With continued advancements in space technology, astronomers hope to refine their predictions and gain a better understanding of when Betelgeuse might explode. Until then, we can only watch, wait, and wonder. Will we be the ones lucky enough to witness the cosmic spectacle of a lifetime? A star on the brink of history. Betelgeuse remains one of the most fascinating and unpredictable stars in the universe. Whether it explodes tomorrow, in a decade, or in 100,000 years, it will ultimately meet its fate as a supernova, leaving behind a stunning celestial legacy. For now, it continues to captivate scientists and stargazers alike, serving as a powerful reminder of the vast, dynamic, and ever-changing nature of our universe. So the next time you look up at the night sky, take a moment to find Orion's shoulder, because one day, Betelgeuse may shine brighter than anything you've ever seen before. Moving toward its destruction, researchers keep on looking for indications of when it will at last detonate, as nobody knows the exact second. Betelgeuse is believed to be significantly more massive than the Sun, and specialists anticipate this brilliant red star to shine for the next decade. However, given the unusual behavior of the star, it is difficult to say if this prediction will turn out as expected. After the major dimming event, for the time being, researchers do not expect that Betelgeuse will explode in the immediate future. However, when it does, it will be the first supernova observed in modern times since Johannes Kepler's observation in 1604. Researchers do not believe it will happen soon because they are still trying to understand the star's unpredictable behavior. Regardless of this uncertainty, when Betelgeuse does eventually explode, it will be a rare and fascinating astronomical event. When it finally goes supernova, it will emit an enormous amount of energy, momentarily shining brighter than the entire galaxy and appearing as bright as the full moon from Earth. The supernova will be a wondrous cosmic event, but it will not pose any direct threat to Earth, as Betelgeuse is over 600 light-years away. Nevertheless, it will provide a significant opportunity for researchers to study the final stages of a massive star's life and the phenomena associated with such a violent event. Betelgeuse's inevitable destruction is not just a scientific curiosity, but also a reminder of the vast and unpredictable nature of the universe. Stars like Betelgeuse play a vital role in the life cycle of galaxies, enriching the universe with elements essential for the formation of new stars, planets, and possibly life itself. The death of such a star is not an end but a transformation, as it releases heavy elements that will seed new celestial systems. Meanwhile, researchers continue to observe Betelgeuse, piecing together the puzzle of its future with each new discovery. The mystery surrounding it deepens, expanding our understanding of the universe. Perhaps, in the years to come, we will witness one of the most remarkable events in the cosmos, the transformation of Betelgeuse from a massive red supergiant into a stunning supernova. Until then, the sky will remain a canvas of wonder, with Betelgeuse shining brightly as a reminder of the transient nature of life in the universe. Betelgeuse's transition into a supernova is an event that will capture the attention of astronomers and skywatchers alike. Although we are uncertain when exactly this transformation will occur, the star's current instability has sparked waves of speculation about its future. Advanced instruments and technologies at our disposal, such as the James Webb and Hubble Space Telescopes, have provided astronomers with unprecedented insights into the behavior of this remarkable star. As Betelgeuse's brightness fluctuates and its irregular changes continue, researchers are carefully analyzing data in hopes of understanding what triggers these variations. The star's extreme variability could be a precursor to the violent explosion that will ultimately mark the end of its stellar life. Whether Betelgeuse will explode within the next few years or in a significantly longer time frame remains uncertain. However, one thing is clear: the universe is full of cosmic surprises, and Betelgeuse's eventual demise will be a spectacle that brings new opportunities for discovery. Over time, astronomers have observed and studied countless stars, but few have garnered as much attention as Betelgeuse. Its enormous size, variable brightness, and unusual color have made it a subject of intense research. As a red supergiant, Betelgeuse is already in the final stage of its life cycle. The star's massive size means that it will eventually exhaust its nuclear fuel, leading to its ultimate collapse and subsequent explosion into a supernova. This explosive event will release an astounding amount of energy, dramatically altering the surrounding cosmic environment. Despite the many uncertainties surrounding the exact timing of Betelgeuse's supernova, astronomers agree on one thing: the star's inevitable end will be one of the most significant cosmic events of our lifetime. The data being collected by today's most advanced telescopes is helping to unravel the mysteries of the star, providing crucial information about the processes that occur during the final stages of a star's life. By studying Betelgeuse's behavior, researchers can gain deeper insights into the broader mechanics of stellar evolution. Furthermore, the explosion of Betelgeuse will likely leave behind a lasting impact on the surrounding space, enriching the interstellar medium with heavy elements that will eventually become part of new stars, planets, and possibly even life forms. This cycle of creation and destruction is a fundamental aspect of the life cycle of stars, and Betelgeuse's supernova will be a prime example of this cosmic process. As we continue to observe Betelgeuse and other stars in similar stages of evolution, astronomers are utilizing cutting-edge technology to better understand the forces at play. The James Webb Space Telescope, with its unparalleled ability to observe distant objects in the universe, is providing a wealth of data that will shape our understanding of stellar dynamics. The images and measurements captured by this telescope are shedding light on the complex mechanisms that drive a star's evolution, from its birth to its ultimate demise. Although the death of a star may seem like a destructive event, it is, in fact, a crucial stage in the ongoing cycle of stellar evolution. The elements released during a supernova contribute to the formation of new stars, planets, and potentially even life. In this sense, the death of Betelgeuse, and stars like it, is not an end but rather a transformation that fuels the birth of new celestial bodies. Ultimately, Betelgeuse's supernova will play a significant role in the ongoing evolution of the universe, contributing to the creation of the building blocks for future generations of stars and planets. Until the day Betelgeuse finally explodes, astronomers will continue to observe and study its behavior, deciphering the signs that will help them predict its future. The star's unpredictable dimming and brightening cycles, as well as its other strange behaviors, make it a fascinating subject of study. With each new discovery, researchers are learning more about the processes that govern the life cycle of stars and, by extension, the evolution of the universe itself. The mystery surrounding Betelgeuse's fate serves as a reminder of the vastness and complexity of the cosmos. The universe is filled with untold wonders, and the study of stars like Betelgeuse allows us to glimpse the incredible processes that shape the fabric of reality. As we continue to explore the cosmos and expand our understanding of the forces that govern it, we are reminded of the fleeting, transient nature of existence. The stars, including Betelgeuse, shine brilliantly in the night sky, offering a glimpse into the extraordinary and ever-changing universe in which we live. As astronomers keep a close watch on Betelgeuse, they are gathering more data that may help predict when this colossal event will occur. The star's irregular dimming patterns and increasing instability suggest that it is undergoing dramatic internal changes. While some theories propose that Betelgeuse could explode within the next few decades, others suggest that it might still take thousands of years before reaching its explosive finale. When Betelgeuse finally goes supernova, the event will be unlike anything witnessed in modern astronomy. The explosion will send shockwaves through space, expelling vast amounts of stellar material that will enrich the surrounding interstellar medium. The energy released will be so immense that it could briefly outshine an entire galaxy, making Betelgeuse visible in daylight from Earth. Despite the grandeur of this event, the explosion will not pose a threat to life on Earth. Betelgeuse is located more than 600 light-years away, far enough that its radiation and shockwaves will dissipate before reaching our planet. Instead of danger, its supernova will provide scientists with an unprecedented opportunity to study the final moments of a massive star's life in real time. Astronomers will closely monitor the explosion using powerful telescopes like the James Webb Space Telescope, the Hubble Space Telescope, and next-generation observatories yet to be launched. These instruments will capture detailed images and data, allowing researchers to analyze the physics of supernovae, the formation of neutron stars or black holes, and the dispersal of heavy elements across space. One of the most exciting possibilities is whether Betelgeuse's explosion will leave behind a neutron star or collapse into a black hole. Given its estimated mass, it is more likely to form a neutron star, a dense, rapidly rotating stellar remnant. However, if Betelgeuse is at the higher end of mass estimates, its core could collapse entirely, forming a black hole. If that happens, it would provide a rare opportunity to observe the birth of a black hole relatively close to Earth. As the remnants of Betelgeuse's explosion spread through space, they will contribute to the ongoing cosmic cycle of destruction and creation. The elements forged in the heart of the dying star, carbon, oxygen, silicon, iron, and many others, will eventually mix with interstellar gas and dust, potentially forming new stars and planetary systems in the distant future. The death of Betelgeuse is a reminder of the ever-changing nature of the universe. While stars like our Sun will burn for billions of years, massive stars like Betelgeuse live short but dramatic lives, ending in spectacular explosions that shape the cosmos. For now, Betelgeuse remains a bright and fascinating object in the night sky, an ongoing mystery that scientists are eager to solve. Each new observation brings us closer to understanding its fate, and when the moment finally arrives, the entire world will bear witness to one of the most spectacular events in astronomical history. Until then, the star continues to shine, a beacon of the incredible processes that govern the universe, reminding us of the vast, intricate, and ever-evolving cosmos we call home.